So taking this quick sort, we shall see some interesting inputs for this. So one interesting input is if the entire input is in ascending order, which means if the given input is like this 1, 2, 3, 4, 5, 6, then what happens if we apply the quick sort? What is the total time required? So for that, just observe this. If I call the partition on this input, partition will take 6 as the pivot, the last element as the pivot, and as usual j will try to find out an element which is less than 6, right? J will start from the first element till the last but one element and will try to find out some element which is less than 6, and I will start from one element less than j, right? Then what happens? J has found the element which is lesser than 6, then I will get incremented, then there will be a swapping, which means exchange a of I and a of j, which means one will be there, then j will be incremented, right? And now what happens? J has been incremented, and again if we found an element which is less than 6, then I will be incremented, and again these two will be exchanged. Exchange means the same element will be there. Same thing happens here, j and I, right? Which means j will keep on finding an element less than 6, and I will try to come there and will exchange it with itself, right? Then j and I. So this is where j is going to stop. So after this stops, then we are supposed to exchange I plus 1 with pivot. So what is I plus 1? 6 only. Exchange 6 with 6. So that nothing is going to change. Only thing is, after partition, 6 will be in its right position, exact correct position. Then again we have to call quicksort on the elements left to that, and quicksort on the elements right to that, right? There are nothing, right? Therefore, if the element, if the array is in ascending order, if the ascending order input is given, then the total time taken to sort n elements will be, first thing is we are applying the partitioning algorithm, which is going to take order of n time, isn't it, for the partitioning algorithm. And now we got a sub problem whose size is only one element less. This is what we got, right? So even if we apply one more time, we get the same thing, isn't it? And this is going to happen continuously. See, if I apply partitioning on this, again this one will be taken as pivot, and this one will be, j will start from here and it will try to find some element less than or equal to 5, and I will start from outside, right? So initially it found an element which is less than 5, then I will be incremented, and a of I and a of j will be exchanged, which means 1 will be exchanged with 1, so 1 is going to be there, right? And then j will again find the next element which is less than 5, I will be incremented and exchanged. J will again find an element less than 5, I will be incremented and exchanged. J will be again finding an element less than 5, I will be incremented and exchanged. So we are going to get the same thing, right? Only thing is, after this again we are going to see that the size of the problem is exactly 1 less than the size of the previous problem. Therefore this rule holds, which means t of n equal to order of n plus order of plus t of n minus 1. If we solve this by putting some constant cn, so in order to solve this, you can put a value cn here, and you can do that back substitution. We have already seen that. So we can find out that this time complexity is order of n square. Therefore, if the input is in ascending order, then the time taken to sort that is order of n square. Let's see one more input which is in descending order. If the input is in descending order, like 6, 5, 4, 3, 2, 1. If the input is descending like this, then initially you are going to call quicksort on this, then quicksort is going to call pivot on this, then the pivot partition on this, and partition is going to pick the last element as pivot, right? And what will j do? J will try to find out an element which is less than the pivot, so which is less than 1. So it will scan the entire list till this part, and it will fail to find any element which is less than 1. So j is going to stop there, and I will be wherever it was, 1 less than j initially, right? And finally j is, we are going to exchange the pivot element with I plus 1, which means this element will be exchanged with pivot element 6, right? Now this is where the pivot element is located, right? So we found out that the entire problem, if the problem given is of size n, then we are going to apply the partition algorithm. Partition algorithm, j is going to run from here to here, therefore time taken is order of n. After that, the size of the problem is reduced only by 1, which means t of n minus 1, I have to solve it again, right? So even if you try to solve this again, then you will see the same thing. See this? Now if I try to apply quicksort from 5 to this 6, then 6 will be taken as the pivot element initially, and j will start so that it will find the element less than 6. So initially I will be here 1 less than j. Now j has found an element less than 5, then I will be incremented and these two will be swapped. If I swap, we are going to get the same. Then j will get incremented until again find an element less than 6. Then I will be incremented and then swapped, which means we get the same. Then again j will be incremented and we found an element less than 6. Therefore I will be incremented and these two elements a of j and a of I have to be swapped, which means I get the same. And j will be incremented, again j will find an element less than 6. Therefore I will be incremented and these two will be swapped, again I get the same. So j is going to start from here and it is going to end here. And finally what should happen? This pivot has to be exchanged with I plus 1. I plus 1 is same. So pivot is this, pivot location is this, right? So now the problem is again divided into n minus 1 only, isn't it? If the given elements were 1, 2, 3, 4, 5, then I got a list of 1, 2, 3, 4. So this rule is following, which means if the given element size is, if the given array size is n, then I am going to apply partitioning for which the time taken is order of n, and then the problem size is reduced exactly by 1. So even if you solve it, it is going to be order of n square. So even if the input is in the ascending order or in the descending order, the time taken is going to be order of n square and both the times are same. And one more interesting input is, if all the input, if the array contains all the numbers which are equal, which means if I contain this 2, 2, 2 like this, if the entire array contains the same elements, then how are we going to solve it? So first thing is, this last element is going to be pivot element. See, if I call the quicksort on this, then quicksort is going to call partition on this, right? So this last element is chosen as pivot element. Then j will try to find an element which is less than or equal to 2. So j will start from here and will try to find an element less than or equal to 2. Yes, it found it. Therefore I will be incremented and a of I and a of j will be exchanged, which means 2 will remain there itself. Then j will go to the next element and I will be incremented, right? I mean j has found the element which is less than or equal to, j has found an element which is less than or equal to 2. Therefore I will be incremented and again exchange, which means same. Then again j will be incremented and it will find an element which is less than or equal to 2. Therefore I will be incremented and swapped, which means same. J will be incremented, it has again found the element less than or equal to 2. I will be incremented, right? And again swapped. The same thing is going to happen. Finally I plus 1 has to be exchanged with the pivot, right? So which means by the end of the partition algorithm, this 2 is going to remain in its same location, which means the partition algorithm is going to return that the size of the problem is n minus 1. So after one partition algorithm, we are going to, if I have to sort n elements in which all the n elements are same, then I am going to apply the partition method, which is going to take order of n time, and then I am going to get a list whose size is n minus 1, right? The same algorithm, therefore it is going to take order of n square, right? So either if the input is ascending or if the input is in the descending order, or if all the elements are going to be same, then also it is going to be if all the input size is going to be same, the order of the time complexity is going to be order of n square. So ascending, descending and same elements all are going to have the same complexity, which is order of n square. So if you analyze the time taken by this quicksort, it is mainly because of the time taken by the partitioning algorithm, isn't it? So what is partitioning algorithm doing? So partitioning algorithm is going to take order of n time and it is going to place exactly one element in its correct position. In worst case, what happens is, in order to put every element in its correct position, I might have to call partition, which means I might call partition n times, and every time if it takes order of n time, then it is going to take order of n square time. That is what is happening here. So every time partitioning algorithm is going to take, see this, initially there will be n elements, right? Then it is going to take order of n time, which means Cn time. So why is this happening is, I'll just show you. So the major part of the time taken by this quicksort is because of the partitioning algorithm, isn't it? Now if the partitioning algorithm is, how much time is it going to take? If the input is of size n, then the partition algorithm is going to take, let us say, some constant into n, which is nothing but order of n time, right? This is the size of the input, then this is the time taken by partitioning algorithm. Then what is it doing? It is trying to place one element in its correct position, right? Then what is happening in the previous problems is, only one element is getting placed in the partitioning algorithm by the partitioning algorithm, and then all the n minus 1 elements are remaining as it is, right? Then what is happening is, again for the remaining n minus 1 elements, we are again going to call the partitioning algorithm, which is going to take c into n minus 1 time and going to put only one element in its correct position. Then how many elements were remaining? N minus 2. Then again we are going to call partitioning algorithm on the complete n minus 2 algorithm, right? That is why it is getting like this. But then only one element is going to be placed. So on, finally I get one element, right? Then if we add all of them, it is going to be order of n square. Got it? So there are some proofs. We shall see some more problems and analyze the quicksort time complexity again. So for now, you remember that either it is ascending order or descending order, or the given elements are same. The time complexity taken by this quicksort is worst case time, which is nothing but order of n square. And what is the best case time? Best case time, we have seen that if the partition algorithm is going to partition the array into two equal halves, then T of n, in the best case, partitioning algorithm is always going to take order of n time, and in the best case, if both the problems are going to be partitioned equally, nearly equally, then we are going to get n log n time. This is the best case. In best case, we are going to get n log n, which is close to merge sort, and in worst case we are going to get order of n square. And now just now we have seen the inputs which will lead to order of n square: ascending order, descending order, and same elements, right? So let's see what happens if it is not, if every time we are dividing it like this, 1 and n minus 1, sorry, 0 and n minus 1, and then 0 and n minus 2, and then 0 and n minus 3. This is what we have seen. Instead of this, if there is some ratio in which we are dividing the input into, like 1/10 of the input one side and 9/10 of the input other side, let's see what happens with that input. So in the previous three examples, we have seen that initially n size was the input, and I was dividing it into 0 and n minus 1, and again 0 and n minus 2, and again 0 and n minus 3, and at every level the work done is nearly order of n, right? So work done is nearly order of n, right? And how many such levels are there? N levels. Therefore total work done is order of n square. That was the time complexity. We got order of n square if it is ascending order, descending order, or same sequence, right? What if the partitioning algorithm is going to split the input in such a way that the size of two lists or the size of two subproblems we get are in the ratio of 1:9, which means if you are giving me a size, n elements as the input, then it is going to divide into n/10 and 9n/10, right? So ratio is 1:9. Then it is doing it constantly, which means every time it is going to give me the split 1:9. So previous examples were 0 and n minus 1, but now it is n/10 and 9n/10. Then what happens is n/100, 9n/100. 9n by 100, right, 81n by 100, right. So on, this will reach one element, right, and then this will be, next time it will be 81n by 1000, 729 by 1000n, right, and so on, it will reach one element, right. But then if you see the depth of this left side child is going to be less compared to the depth of right side child. But at every level, the total work done will be order of n, right. Either you run it on complete n elements or n by 10 elements and 9n by elements. The partition algorithm has to actually run the j loop over all the elements. So here all the n elements, here n by 10 elements first and 9n by 10. So however, the total work done is going to be order of n only, right. So let me call it as some constant c into n. So c into n, and this is also going to be c into n as long as all the levels are full. So till this level it is going to be c into n, and then after that the elements are going to stop here, right. So some of the elements are going to stop here and it is going to continue, which means here I will not have, for the next level, n elements that will be less than n elements, which means less than c into n, less than c into n, and finally it is less than c into n work. So the work done is going to be decreasing. So it is going to be c into n till some level, and after that it is going to be less than c into n, right. Then if the work done at every level is like this, then how many levels are you going to have at max, right? At max you can find out that the number of levels in this tree, see this, the levels are decreasing like this. At first level the size is n, and at the second level size is n by 10 by 9, and at the next level the size is n by 10 by 9 whole square, right. So on, it is going to reach 1, which means it is not decreasing by half, it is decreasing by 10 by 9. Therefore, how many levels will be there here? It will be log n to the base 10 by 9, and you can think of it as it is nearly equal to log n base 2, or you can say that this is equal to theta of log n base 2. There will be some difference definitely, but then you can, by putting some constant here, by multiplying with 0.1 or 10, you can say that these two are like this, related by this. Therefore, number of levels in this are roughly equal to log n, and at every level we are doing a work of cn. Therefore, what is the total work done? So total work done is nothing but theta into theta of n log n, right. So from this we have seen that even if the split is 1:9 at every level, we are going to get the best case time complexity, which is order of n log n. So it can even be proved that even if the split is 1:99, or even if the split is 1:999 at every level, then also we might get the best case time complexity theta of n log n. Keep this in mind. So if the split is not as bad as 0 n minus 1, then we are going to get on average n log n as the time complexity, right. So one more interesting thing is, let us say at one level we are getting the best time complexity, and the second level we are getting the worst. I mean, at one level we are getting the best case, and at next level we are getting the worst case. If the cases are alternating, which means if at every level this proportionality is not being followed. Let's consider one more example. Let us say we are given n elements to sort. Then after applying partitioning algorithm, which will take cn time, I got the worst case inputs, which means one side I got 0 and other side I got n minus 1 elements, worst case, right. And again on this n minus 1 elements I have done a c into n, nearly this c into n minus 1 constant time work. Then again now I got best case split. What is the best case split? N minus 2 elements by 2, n minus 2 elements by 2. The reason is, why am I writing like this is, the reason is like this. See this, n minus 1 elements, out of which one element will be placed in its correct position. Then how many elements will be remaining? N minus 2 elements. Now let us assume that n minus 2 is evenly on the right hand side and the left side of the pivot element. Then the problem sizes could be like this, right? In this case, see what happened. Initially I had to sort n elements, for which time taken is t of n, for which I did a total work of Cn and Cn, which means Cn plus Cn work I did, right? Plus then the problem got divided into two sub problems, right? And each of size, the problem now got divided into two sub problems, each of size n minus 2 by 2. And if this keeps on happening, which means next level it is bad split and next level it is best split. Bad and best, if they are going to alternate, that is if that is the case, then this is what I am getting, right? Then what is this? This is 2Cn plus 2 into t into n minus 2 by 2. Now this 2c is nothing but a constant, therefore I can write it as order of n plus, now instead of writing n minus 2, if I put n, what happens? Definitely right hand side is going to increase. Then I can put less than or equal to 2t n by 2. Instead of this n by 2, I am putting n. Therefore, the right hand side is going to be more. Therefore, I am putting less than or equal to. Then, if you solve this equation, you get theta of n log n by Master's theorem, right? So, even if the split is one level, it is worst split, and second level best split, next level worst split, next level best split. Even if the input is alternating like this, then also I am getting the best time complexity, which is closely equal to the best case time complexity, right? So remember this, we are going to say that the worst case time of insertion sort is order of n square, but that is not always the case. The reason is, even if it is 1:9 split or 1:99 split, or even if it is best and worst combination, then also I am getting n log n, right? So the only cases where I might get order of n square is 0 and n minus 1, 0, n minus 1, 0, n minus 1, so on, which is nothing but ascending order, descending order, or same elements. For such elements, we are going to get order of n square. Otherwise, we are going to get theta of n log n, right? So let's see some problems on this insertion sort. Look at this question. The median of n elements can be found in order of n time. So what is median is the value which is supposed to be the midpoint, right? So if I have n elements, then I am not sorting them, but then I can find out what is the average of it, or what value of it is going to fall in the middle if I sort it out. Okay, median is that. So median is nothing but out of all elements, if I sort them, what element is going to fall in the middle, that element is called median. Okay, now they are saying that we can find out median of n elements in order of n time. Then which one of the following is correct about complexity of quicksort? They are talking about if I use this method in order to find out the median, and then what will be the complexity of the quicksort. Okay, so quicksort, they are saying that they are going to use the median as the pivot element, right? So how can I use the median as the pivot element? So take that partition algorithm. Okay, now that partition algorithm was selecting always the last element as the pivot element, right? Then what you could do is, first step is, given n elements, right? When you run the partition, you are going to find out that some element is the median. So before first given n elements, we can find out in order of n time what is the median, right? And then you replace that median at the end. You put it at the end and you take the last element and you swap it, for which time taken is constant time, right? And now you apply the partition on these n elements, for which time taken is order of n, right? So after applying the partition algorithm on this, then what do you get? Finally, we are going to partition the entire list. So since this element is supposed to be in the middle, we are going to get two lists exactly of size n by 2 and n by 2. Not exactly, roughly of size, right? Therefore, first find out the median, for which time taken is order of n, and then put the median at the end of the list, whatever you wanted to sort, and then you call the partition algorithm, right? And now we get two problems which are roughly of size n by 2 and n by 2, right? Therefore, if you write the time complexity, if I have to sort n elements, then find the median. So how much time is it going to take? Order of n time, right? And then you replace the median with the last element, and then you call the previous partitioning algorithm. See, I am replacing the median with the last element because our partition algorithm was choosing the last element as the pivot element, right? But if your partition algorithm is choosing the first element as the pivot element, then you replace the median with the first element. That depends on what your algorithm is, okay? So my algorithm is choosing the last element as the pivot element, my partition algorithm. That is why I am placing it at the end. Then you run the partition algorithm, for which time taken is order of n. Now after running this, now the entire problem is going to become almost two problems of equal sizes, right? Why? Because the element is median. Then what are you going to put here? We are going to put 2t n by 2 roughly, right? Then what about this entire thing? This entire thing is going to add up to order of n plus 2t n by 2. Now you apply Master's theorem, then we are going to get the time complexity is as n log n. That is what is given, okay? See this problem, they are saying that in a quick sort for sorting n elements, so now we have to sort n elements, the n by 4th smallest element, which means out of all elements, whatever is the n by 4th smallest element is selected as pivot, right? So now for the partitioning, we are going to give n by 4th element as the pivot element using order of n time algorithm. So using order of n time algorithm, we are going to find out what is the n by 4th smallest element, and now we are going to give it as pivot. Then what is the worst case time complexity of quicksort? So what you do is, you better pause the video and you read the question once and you understand it. In the question they are saying that I have an array of size n, okay? Then if I run a order of n time algorithm, then I can find out some element. That element after sorting the list will fall in the place of n by 4, which means that element will be here, 3n by 4 elements will be here after sorting it, right? I can find out such an element in order of n. Now if I am going to use such an element as a pivot element, then what will be the worst case time complexity of quicksort? That is what they asked, right? So how to analyze this? Let us say I want to sort n elements, right? Then first thing is, you run this order of n time algorithm, okay? I am running it, therefore time complexity is order of n to run this algorithm. Then I found out the element which is supposed to be n by 4th smallest. Then what I do is, I will exchange that element with the last element and then run my partitioning algorithm, right? Now partitioning algorithm is going to take, for exchanging that element with the last element, constant time is taken, and then my constant partitioning algorithm is going to run, so which is going to run for this. After my partitioning algorithm, what happens is, pivot is going to sit exactly at its position, and to the left of it there will be nearly n by 4 elements, and to the right of it there will be nearly 3n by 4 elements, right? Therefore now the problem with n elements is resolved into two problems, one of size n by 4 and other of size 3n by 4, which means t of n by 4 and other is t of 3n by 4, right? Then it is nothing but t of n equal to order of n, this entire thing I can write it as order of n, plus t of n by 4 plus t of 3n by 4, right? So this is nothing but, using an order of n time algorithm, I am partitioning the input in a ratio of 1:3. And I have already shown you that even if the problem has been broken into the ratio of 1:9, then or 1:99 or 1:999, even if the problem has been broken like this. still the time complexity is n log n, right? Therefore definitely for this 1:3 we get theta of n log n, because it is better than 1:9, right? And what about 1:1? For 1:1 we have seen that it is going to be n log n, and for 1:3 definitely it is going to be n log n, right? Fine. And one question is this: they are saying that we are using quicksort to sort all the elements, and using quicksort, if I run quicksort on some algorithm, they are saying that if the input is 1, 2, 3, 4, 5, then the time complexity required is T1, and if the input is like this, they are saying that if the input is 1, 2, 3, 4, 5, so on n, which means all the elements are in ascending order, then the time taken is T1, and they are saying that if the input is n, n minus 1, n minus 2, so on 1, then the time taken is T1. Then they are asking you what is the relationship between T1 and T2. We have already seen that either if the time, if the elements are sorted, ascending order or descending order, or if the elements are all equal, then also we are going to get T1 equal to T2 equal to big O of n square. So in this case T1 is equal to T2, right? And in other problem they are saying that so using a partitioning algorithm which takes order of n time, we are splitting the problem into two parts. One part contains 1/5 elements and the other part contains 4/5 elements, right? Then what do you say about the time complexity, right? Then how can you write the time complexity? T of n is equal to order of n plus T of n by 5 plus T of 4n by 5. Okay, then how can you again simplify it is, so it is less than or equal to big O of n plus which one is bigger? I cannot write 2 into T of n by 5. I can write 2 into T of 4n by 5. Okay, why? Because this factor is less than this factor and I am replacing both the factors with 4n by 5, therefore I can write like this. Okay, so these are some of the questions which have been asked in exam about quicksort. Okay.